This man is here to wake everybody up with his amazing energy. Matteo Collina, everybody.
Hi, guys. Okay. Oh, so everybody, this is a front-end track, and well, yesterday we spoke a lot about microservices, and well, let me present you a new approach for building microservices architecture, which is, I don't know, let's call it full stack through microservices. So why through? I think you all know through from Dominic Tarr and as a general approach of building applications, which means that, okay, let's just try building services, just piping stuff one into each other, okay? That's the cool thing about Node and streams, just pipe stuff. Well, little bit of introduction. Hi, guys. And this came out of my experience. I'm an Internet of Things guy most of the time, also a Node developer, and whatever. This came out of my experience, so anyway. Well, where do we come from? And what's happening and why this might be sane or insane, I don't know. You decide. How we distributed services from the beginning, okay? Well, in the beginning, there was this RPC thing, which was really a thing back in the days, right? And, well, the remote procedure call for everybody. And, well, the first commercial system that popped out was kind of Sun and NFS, I don't know. I studied the stuff at school, which some of you maybe experienced it. I've coded some of the stuff. Okay, so, well, I don't know. It was not really a super pleasant experience, anyway. Lots of stuff going on. And then things got really worse. I don't know how many of you work with Java RMI. Yeah, okay. Things from the Sun stuff to Java RMI, things got really worse because Java RMI just pretended that a function was kind of local, and Java RMI just pretended that objects were local and were remote instead, right? So I don't know, things were not really going well in this camp. Then we came out and some great work on Substack, and we have dnode, and it was really great. You can just pop out a server, our RPC server, very easily. And you can, well, it just always based on the request response pattern anyway, right? It's RPC, but still it's built on streams. You can run it in the browser. You can compose system in a very nice ways on it. It's based on a JSON message format, nice JSON stuff. Works in the browser. However, still data must be ready before calling the RPC, right? It's RPC. So I send some data input in, and I get the result back. That's it. We have no live feeds. All in RPC, we don't have live feeds. Then we have REST, right? If we are not doing RPC, we are just using REST. Representational states transfer, okay? I hope all of you know about REST at this point in time. Well, okay. How many of you have read the work from Roy Fielding? Okay, you guys are all my respect. Most people doesn't really have studied REST the way it's supposed to work. We just say, okay, we have read some book about REST, whatever. Still, it's not, okay, most of what is called REST these days is still not REST in a pure way of things. To some extent, REST is mostly used as a nicer version of RPC. Okay, from our web apps, we just call it, okay, just issue a post request somewhere. Still, we have no live feeds, okay? How many of you use server-sent events? Okay, guys, okay, some people. Server-sent events are really nice. Still, it's a nicer way we can have live feeds on a REST resource. Then we have WebSockets, okay? And WebSocket is not really REST. Is completely not REST, right? It's completely violating of all the HTTP and web patterns. And we have frameworks for doing REST, like Happy and Restify and Express and all the kind of stuff. But then we have completely a different set of frameworks for doing all the stuff that is WebSocket and stream-based and all the kind of different stuff. These two words doesn't talk between each other. So what does Docker have any sense in all this thing? Okay, lots of talking about Docker stuff. I'm talking about today some Docker stuff too, which is not really related to Docker, the container system. Let me cite Solomon, the Docker creator, whatever, CEO of the company. Okay, so all the RPC systems are built on the idea that we call function locally. And instead, it's just a remote thing, okay? So let's just think completely in a different way. If you are building a microservices architecture, we might want to have a microservices in our process on the client anywhere. Let's just think everything is connected like on the network. And let's pretend it's over the network, even if it's not. Well, where does this went? In a library called libchan. You might have heard about it, also related to libswarm, whatever. It's built in Go. I don't know. There are going to be great stuff about this library from the Docker company, not telling anything of it. It's built on Speedy. I hope all of you know about Speedy at this point in time. There's a very nice implementation of Speedy from Fedor, which is speaking later, so anyway. Very good stuff. It's built on Speedy, and it's like Go channels over the network. It's built on message pack, okay? So it's binary, fully binary. Anyway, all the transport is binary. You can send over messages, the kind of JavaScript objects, arrays, whatever. It uses the latest stuff of message pack, specification of message pack, which is not compatible with all the library out there. Let's see that in a moment why this happened. And it's unidirectional. So I open a channel to you, to some of you. I open a channel to Michael, and I'm sending messages. And the messages just flow from me to him, okay? So how can we build a system with that stuff? How is possible? How can I get the value back? So, well, first thing, you send a request. And, well, no response, because it's just one way. Okay, so, okay, I can send a return channel in. So I have a stream, and inside the stream, I send another stream. And that stream, for me, is readable, okay? And for Michael, it will be writable, okay? And we can send not just one, 42, whatever. Doesn't care. It's not limited. You can send all the streams you want in, and they got on the other end as streams. How this works, because we use some custom types for message pack that was introduced in the latest release of message pack. So it also supports binary streams. So if you read a file from the file system, you send it inside the channel, and it gets there as a stream. And when back pressure and all the kind of stuff, it pops there. Nice one. Yeah. So what I'm presenting today, I'm presenting JSChan, which you might think what it is just the port of libchan to Node and the browser, okay? I'm putting a star in the browser. I don't know if you can call Internet Explorer a browser. As it requires some really new tech, it won't work in Internet Explorer less than 11, okay? And which, I don't know, it's a big chunk of the market anyway. It depends on binary support on the browser and WebSockets and all that kind of stuff. At the moment, well, you can build fallbacks, but still, we didn't do that. Each channel for us, it's just inherits from Transform. You might know Transform from Node Core. And you just manipulate channels via through. And you can, well, I really like the through fashion, but anyway, you can use whatever you want. It's just streams. You can use on data if you like on data. Don't care. And you just build microservices composing this technology in that way. We support Speedy, okay? Speedy is the same stuff of libchan. It's fully compatible with libchan, so you can develop a service in Go and call it from Node and vice versa. We also support a WebSocket thing, so we can call microservices right from the browser. I'm doing that right now in this presentation. We'll show you in a moment. However, this protocol is not in the libchan specification. It's just something we built. It's just plain message pack over WebSocket. It's way simple. Okay, this is the SpeedyI specification. Maybe Fedor can say one or two things about it. And this is my specification for this protocol, which has much less stuff in there, but well, just works. Anyway, this is just a little bit of code for libchan, for JSChan. So we create a Speedy client, specify a port, create a write channel, and send a big chunk of stuff there, okay? What we are sending, we are just asking for a remote command execution, all this kind of stuff, okay? Security guys, don't listen. This is just a weird example. I'm just executing a process remotely. You can do bad stuff with this code, don't run it in production, okay? I'm sending a command and the arguments, status channel for getting the exit code, and the standard error, standard output, and standard input. Know that I'm just passing through process standard in and all the stuff. It's just stock node stuff. I'm not piping, not doing anything. So this is the server counterpart of it. We have some events emitted. The server emit a session. The session emit a channel. And the channel, finally, we can do stuff with it. This is a little bit of boilerplate code. It's in there. And it's just in next slide because it doesn't fit in one slide, the actual thing. So we are creating the process, like child process.spawn, with the commands, the arguments, and we are just piping, connecting our incoming streams to the actual stuff. Note that this service is just does any requirements on it being local, remote, or anything. If that request contains just the stock process standard input, it will just work anyway. Okay, it's just the same piece of code that can run anywhere. So, well, what can we send on a channel? Well, we send anything that can serialize as JSON, and we can send binary streams, readable, writable, and duplex. We can send other channels, as we have seen. Well, obviously, they are streams, okay? It's back pressure. Well, let me introduce another new thing. Okay, on top of JS10, we built Graph. What is Graph? Well, this is just the actual thing, full stack through microservices. It's the microservice framework that sits on top of all this session and channel goodness. So you create a new Graph instance, you require through-to. I'm a fan of through-to, but anyway. And you just pipe things. And this is just how you build your web service thing. You just pipe stuff. Well, how does this work? Let's build a simple other service. So this is another service. It's just, I don't know, a transform thing. We get a message in A and B, and we send the sum back on the return channel, and we close the thing, right? We can call this stuff locally. It's really easy to call this thing locally. It just works. We have a new Graph instance, and we pipe it to the other service we require. We send our message A, B in the return channel, and then we print the result. How can we expose the service? Very easy. We require graph/speedy. We open a server, and when it's ready, okay, we print some stuff, and then we pipe to the module.export of the other JS file. Okay? And yeah. So, well, where the channel and session ended up in this thing? They are just non-enumerable properties on the message object. So when you receive a request, you got this underscore channel underscore session thing where you can put, I don't know, authentication and all this kind of stuff. These two stuff are not connected, okay? We can also call the service remotely. We can actually, it's actually the same example as before, it just works the same way, it is the same output. However, instead of requiring the service locally, we just pipe to a speedy client, and we just get back the result. We can even have some orchestration support, okay? Which is kind of the thing, okay? We are building a massive microservice architecture. We might want have orchestration, some conditions, I don't know. Route these messages to that service, route these other messages to this service, or route these messages to A and B, okay? And we have this, we support that, okay? We can have this nice syntax where you can specify an object which is to be included in the request, and what's matching goes to the second argument. And if not matching, goes back in the pipeline, okay? And this actually shows another nice thing that we are exposing a PD service, a service exposed through PD through WebSocket. Okay? So, demo app. I am an Internet of Things guy. Okay? And I'm doing an example from the Internet of Things. So, this guy, you see this? This is a TI Texas Instruments sensor tag, $25. You can buy it, shipping included, shipping and battery included, so you can start playing with it. It has a very nice module, Node.js module called sensor tag, which you can get data from this guy. It has 2 buttons, which I'm using to turn in the slides. And in fact, this thing is exposed as a microservice from this HTML5 presentation. So actually, when I click, the data gets back to my app. And I also have a temperature sensor and whatever, humidity, gyroscope, whatever. OK, so what's hooked up? This is the temperature sensor. We have, I don't know, ambient temperature of 25 degrees, don't know. If you are into Fahrenheit, sorry guys, I don't get Fahrenheit. And we have also an object sensor. It's infrared, so if I close the thing, it should go up. OK, and if I move, it should just go down. We also have a humidity sensor, which is, this is still live. Good to be Ireland, I don't know. Which also support like request response stuff. Okay, so we can just get the last temperature, and we get the value. Okay. And well, what's in the to-do list for this thing? Okay, so lots of testing, new stuff. We pushed the first kind of good enough release last week. So yeah, very new stuff. Please get back with feedbacks and ideas and whatever, please. One cool thing is service discovery, okay? You are just as a stream, so you can just, I don't know, stop the stream, pause the stream, reconfigure yourself when your service topology changes, and restart the stream, okay? They're just streams. More transports, okay? I've just showed PD and WebSocket. It can run on a TCP socket. No issue. You can run, I don't know, wherever you have node streams, okay? So things almost everywhere right now. Okay, authentication is still an issue, but as you have the same framework, you can just have the same authentication for all your RPC style requests and also your, I don't know, live feeds and whatever. Okay, so we want to support HTTP REST because still providing REST APIs makes a lot of sense. So HTTP and REST support needs to be done, and so you can call from HTTP REST all your tons of microservices, and hopefully lots of feedback from you. Okay, so I'm not alone in all this. I'm not the only Met guy. There are some others, and one is Adrian Rousseau. I don't know, I think, hi Adrian, he was over there. Long Skype calls on this issue, and thank you so much for all your, for the work together. It's been really a good, really nice journey, and let's think it's a longer one. Yeah, and also Peter Elger, which is not here because he's working like crazy for the deployment workshop tomorrow. Please come. And obviously me, because otherwise, what should I be doing up here? And that's me. I am just mostly an open source developer, so whatever. I work for nearForm. Yeah, t-shirt. And anyway, thank you guys.